Hi ladies and gentlemen, in this video we see about decoders. So we see about 3 to 8 line decoder, a 2 to 4 decoder and something called BCD to 7 segment decoder. So let me start with that presentation. So what you will learn in this videos are your learning outcome, the decoder, the principle of a decoder circuit, then the 3 to 8 line decoder with IC 74138 and 2 to 4 decoder with QX. Then you will learn about a 7 segment decoder, that is a BCD to 7 segment decoder. And you will appreciate the wiring diagram of such a decoder with the help of the IC 7447. Then summary of understanding. So what you will learn in this video, you will learn the operation of n to 2 raised to n line decoder, like a 2 to 4 decoder or 3 to 8 line decoder, that way. Then you will learn to implement a 2 to 4 decoder in QX. Then you will learn to implement a 3 to 8 line decoder using the 74138 IC. Already you have seen this IC in demultiplexer. It's a demultiplexer bar decoder IC. So it is the same wiring diagram that you will be seeing, that except a minor change. Then you will learn the operation of a BCD to 7 segment decoder. That is, sometimes you have to display BCDs, the values from 0 to 9 on some displays, something called 7 segment displays. So you need a decoder in between the BCD and the 7 segment display. So such an IC is the 7447. You will familiarize that wiring diagram. Then a decoder has multiple n lines, n input lines and 2 raised to n output lines. One of the 2 raised to n output lines get active depending on the input pattern. Say suppose if the input pattern or the select pattern is 000, the first line I0 becomes active. If it is a 001, the first line gets active, that way. So the 2 to 4 decoder based on structure, it looks like this. This is something very similar to your 2 to 4, 1 to 8, 1 to 4 demultiplexer, except that instead of the data, here I have something called an enable pin. This is common for many signals. This is an active high input enable. So if this is kept high, this circuit will work. So if these select lines X, Y are 0, what will happen? I0 will be active, I0 will be high. If it is a 0, 1, then I1 will be high. And if this chip is selected, assuming that this chip is selected, then X, Y, if it is a 1, 0, then I2 will be selected. And if it is 1, 1, I3 will be high. So this is how the truth table look like. If this AB is inputs are 0, 0, 0, 1, 1, 0, 1, 1, then outputs I0, these are actually Y0, Y1 are actually I0, I1, I2, I3. These are actually I0, I1, I2, I3. This can, when it is 0, 0, Y0 is 1, I0 is 1. It is 0, 1, next output is high, that way. So now we have to see a 3 to 8 line decoder using 74138 IC. Already you are familiarized this IC. The only difference is, if you look into this diagram, it is a same diagram, except that this data input, this has nothing to do here. You have to keep it at a high, except that, that's the only change. You have to keep this data input as a high and apply logic 0 to these enable pins. And you apply the pattern A3, A2, A1, A0 to these 4 inputs, and these O0, O1, O2, etc. becomes low, because this is an active low connection. This is an active low output. So these LEDs are connected here. So when it is a 0, 0, 0 pattern, the first LED will glow, then the second LED, that way. Okay, it has an active low output. So this is how I configure a 74138 as a 3 to 8 line decoder. This is very similar to the 1 to 8 demultiplexer with the 74138. Here the only difference is the D is kept high always. This A0, A2, A2, A1, A0, A3, that's actually A2, A1, A0. These are the input lines, A2, A1, A0. these are three select lines. If these when these select lines count from 000 to 111, these outputs goes low. This is an active low output. Okay, this is how I use 74138 as a 3 to 8 line decoder. Now there is another useful decoder that is called a 7-segment decoder. That's a BCD to 7-segment decoder. Probably you have seen in displays and all. Earlier this was very popular. This 7-segment decoders, or they were very popular, especially in watches, displays and all that. So what it is that this relies on something called a 7-segment LED or 7-segment display. uh, these LEDs are connected as like a figure of 8 pattern. So if all the LEDs glow, then it is an 8. Okay, if F and C do not glow, then it's a 2. If B and C alone glow, it's a 1. That way you can represent the numbers from 0 to 9 with this. Now this is these BCDs are given here. A3, A2, A1, A0 are the BCDs. These are values from 0000 to 1001, 0 to 9 values. Now these should be decoded in such a way that these LEDs glow. Like if it is a A3, A2, A1, A0 is a 1000, that is 8, then all the segments should glow. If this is a 0000, then G should not glow. Okay, so such an algorithm, such a logic is should be implemented between this BCD and this display. Such a circuit is called a 7447. You can make such a circuit with a Karnaugh map, but I don't go into such a design. Here I am using this MSI chip 7447. Now what happens is when this I apply this BCDs at these points A3, A2, A1, A0, then these there are some pins like lamp test, RB1 bar, RBO, those things. Those 3 pins are kept at logic 0 for a correct operation. If they are kept at 1, then the display will not work. I keep them at 0. Then ground is at 8. VCC supply is at 16, and these outputs like 15, 14, 13, they are the connection to this F, G, H, etc. These things that you can put these on breadboard and you can connect them with the short wires. So this 7447 has an active low output, so that when this F gets active, what happens is this point becomes low. So that then this LED has to glow. For this LED to glow, all these LEDs are connected as this is an FN, something like a FND 507 chip or something. What happens is you keep all anodes, connect all anodes together. This is an LED, so that has an anode and a cathode. This is a common anode type connection. So I connect all anodes together and connect to this 5 volt through a 220 ohm resistor. This cathode point is coming here as F. Okay, that is connected to this point. So that when this 15th pin is low, what happens is this cathode is kept low, and from this supply due to this PN junction, I should not say like cathode, anode, etc. These are old old convention. So I should say due to this PN junction, this LED, when this is low, current flows through this thing, and this F glows. Okay, likewise if G is low, then if this G is low, if this connection is there, then this G glows. Okay, now what happens is when A3, A2, A1, A0 are 0, 0, 0, 0, then all these F, G, H, all these outputs A to G, these pins 15, 14, 13, they all becomes low, and all these cathodes are kept at low, so that all this current flows through all these segments and they all glow. Now when it is A3 is 1 and A2, A1, A0 is a 0, or zeros, like it's a 1000 pattern, Then when it is a 100 pattern, what will happen is all of them gets low and all LEDs glow. When it is a 0000, what will happen is except G, something is connected here, G, except G, everything becomes a low. So what will happen? G will not glow, but A, B, C, D, E, F, they all glow. So you indicate there's an indication of a 0. Okay. So when A3, A2, A1, A0 is, I think I made a mistake previously. When I say A3, A2, A1, A0 is it's a 0000, G will not glow. All other things will go. G will be high, all other points will be low. So current will flow through all segments except G, and they will all glow. Now when it is a 0001, what will happen is only B and C will be low. B and C will be low and all others will be high. So what will happen? Only C and B will glow, and that will show a 1. Okay. When it is A3, A2, A1, A0 is a 0001, what will happen is only B and C will glow. Now this is how you set up a 7447 decoder, 7447 decoder with FND 507 common anode display. So you can go to the lab, take these two devices, 7447 IC and FND 507 common anode display, and connect them together, connect to 5 volt and apply different patterns from A3, A2, A1, A0, from 0000 to 1001, all valid BCDs, and you can appreciate this, you can appreciate these numbers coming here, this display coming here. So here I missed one thing, that is I will show you a simulation of the 2 to 4 decoder with the cubes. I forgot this. The earlier circuit I have shown you here, this is a 2 to 4 decoder. Now these are my select lines, S1, that is a 2 nanosecond pulse, and this is a 1 nanosecond pulse. So you can see pattern 0001, 1011, etc. When I simulate this, when AB equal to 00, I0 becomes a high. When it's a 01, I1 becomes a high. When it is a 10, I2 becomes high, and 11, I3 becomes high. So that way it repeats. Okay. So here again, when it is 00, I0 will become high. When it is 01, I1 becomes high. That way this goes. Now this is how I do a simulation with the simulation of the 2 to 4 decoder with the cubes. Now when I come to the end of this session, that is a summary of your understanding. You learn the operation of n to 2 raised to n line decoder, like a 2 to 4 decoder or 3 to 8 line decoder. Now you learn to implement a 2 to 4 decoder in cubes. You saw the AND based diagram and you implemented it with a 2 to 4 decoder. Then you learn to implement a 3 to 8 line decoder with a 74138 by making a small modification in the previous demultiplexer circuit. Then you learned about the BCD to 7 segment decoder, and you appreciated the wiring diagram of such a decoder with the help of IC 7447. And that is the end of this presentation. That is the end of the decoder circuit. I thank you all.